Good day everyone, I am Will Mercy Hernando and today we're going to talk a little about the moment area method and also we're going to solve a sample problem. So without further ado, let's start. So the moment area method is one of the most effective methods for obtaining the bending displacements in beams and frames. In this method, the area of the bending moment diagrams is utilized for computing the slope and or deflection at particular point along the axis of the beam or frame. Now, our problem is problem 9.115. For the beam and loading shown, determine A, the slope at the end A, and letter B, the deflection at the center C of the beam. So the first step is we need to create 4 diagrams. So the first diagram is the free body diagram. The second diagram is the reference tangent diagram. The third diagram is the bending moment diagram. And last but not the least diagram is the M over EI diagram. Summation of forces at point E is equal to 0. Negative AY plus 4A plus P multiplied by 3A plus 2P multiplied by 2A plus P multiplied by A is equal to 0. So AY is equal to 8P over 4. So our AY is equal to 2P. Next is moment at B is equal to AI multiplied by A. So MB is equal to 2P multiplied by A. So our MB is equal to 2PA. So MB over EI is equal to 2PA over EI. So MB over 3AI is equal to 2PA over 3AI. Next is moment at C is equal to AY multiplied by 2A minus PA. So MC is equal to 4PA minus PA. So our MC is 3PA. So MC minus 3EI is equal to 3PA over 3EI is equal to PA over EI. So the third step is we need to get the value of our A1, A2, and A3. So A1 is equal to 1/2 multiplied by A multiplied by 2PA over EI. So our A1 is equal to PA squared over EI. Next is our A2. A2 is equal to 1/2 multiplied by PA over EI minus 2 over 3 PA over EI multiplied by A. So 1/2 multiplied by PA over 3EI multiplied by A. So our A2 is equal to PA squared over 6EI. Next is our A3. So A3 is equal to 2PA over 3EI multiplied by A. So the value of our A3 is equal to 2PA squared over 3EI. Next is we need to get the value of x bar 1, 2, and 3. So our x bar 1 is equal to 2A over 3. Our x bar 2 is equal to A plus 2A3 over 3. So our x bar 2 is equal to 5A over 3. Next is our x bar 3. X bar 3 is equal to A plus A over 2. So our x bar 3 is equal to 3A over 2. In step 4, we choose horizontal tangent at C as reference tangent. So slope at horizontal tangent at C with respect of A is equal to A1 plus A2 plus A3. Since we already have the value of our A1, A2, and A3, we only need to add it. So PA squared over EI plus PA squared over 6EI plus 2PA squared over 3EI is equal to 11PA squared over 6EI. So next is the deviation at tangent A with respect to horizontal tangent at C is equal to A1 x1 plus A2 x2 plus A3 x3 is equal to PA squared over EI multiplied by 2A over 3 plus PA squared over 6EI multiplied by 5A over 3 plus 2PA squared over 3EI multiplied by 3A over 2. So 2PA squared is equal to 3EI plus 5PA squared over 18EI plus PA squared over EI. So PA squared is equal to 18EI multiplied by 12 plus 5 plus 18, so is equal to 35 PA squared over 18E. Also, slope at horizontal tangent at C with respect to A is equal to slope C minus slope A. and the deviation of tangent A with respect to horizontal tangent at C is equal to YA over C. Since slope C is equal to YA is equal to 0, then our slope A is equal to negative slope C over A. Since it's negative, it's negative 11 PA squared over 6EI. So our slope A is equal to 11 PA squared over 6EI. Letter B, the deflection of point C is equal to negative T over C. Since it's negative, it is negative 35 PA cubed over 18EI. So the deflection of point C is equal to 35 PA squared over 18EI.